Hello, everybody. It's great to be here, even though we are doing this presentation virtually. I'm looking forward for this. So, like you have seen and heard, the topic of this presentation is it a dog or is it a pig? So, I'm not a big fan of presentations. So, pretty much, I have got only two slides. Only two slides. One of them you see currently on the slides. So, the title slide. And pretty much what I will want to do with you during this session, which is like 45-minute session, is to actually build something. That's why we don't have a lot of time to spend on the slides, on the presentation. But there is one more slide, which I would like to show you, which will describe clearly what are we gonna to build. So first of all, because we are going to build an application, a model, which will be helping us to say, is it a dog? Is it a pig? Actually, I have got a few items. So as you see, this is a pig. Don't ask me why I have it, but I have it. And this is, it's not a dog. I wasn't able to find a dog, so this is a dog, but we need to stay with the dog. Actually, I also have got a few other items. So this is like a cow, I think so, and some other things. So pretty much, long story short is, we'll try to build a ML model, which will be able to detect what is on the in front of the camera. But also I would like to actually to use it. That's why what we will do, we will also create a website. I already did it, but I will show you this, how does it look like. So this website will capture what is in front of the camera. So next to me, later I will show you, I have got a camera. Whenever we will be taking, whenever I will put an object in front of the camera, we will take a picture, and this picture will be put later on as free. I guess some of you are familiar with AWS, but there are some people for whom AWS is a new thing. So don't worry, this presentation will be pretty much for everybody and pretty much as free as a service where we can store some data. So at this stage, we have got a place and we have got a collection of the data set which we need because we want to build something. We want to build a model, and to do it, we will be using a service which is called a SageMaker. A SageMaker is a ML platform. Actually, a lot of you might be already using this, because if you are using a Tinder, probably some of you are using Tinder, and you are actually also using SageMaker, because whenever you are like swiping left, right, because you are looking for the true love, there is a SageMaker model built on it. So what SageMaker will do for us, we will be using something which is called a Jupyter notebook, which will be a piece of script which will take the data set which we prepared, and then it will train and create a model which at the end we will deploy. But this is not the end of our application, because having a model is one thing, but I would also actually would like to use it. So we will also have got a second website, very simple website. There is no not very complicated, but this time again, there will be like a camera. And again, I will be like putting those objects in front of the camera. But this time I won't be saying this is a duck. I will be using the model which we have trained, which we will train, which we will deploy, and I will ask the model, what is there? Is it a duck, a pig, or anything else? You also see that I've put a service which is called Lambda there. To a long story short, is a Lambda is a microservice. In short, a piece of code which will be like a proxy between our application and the model which will be deployed. So pretty much this is what we want to build, and we'll see if we'll manage to do it. We are doing everything from the scratch, almost everything. So there's a lot of places where something can go wrong. I hope we will manage to do it, but life. So let me switch to the console. For those of you who don't know, this is AWS console. So one of the ways how we interact with AWS services. So first of all, I will want to build this website, which I will be using to build to prepare my data set. So I will want to take like 20 pictures of the duck and so on. So first of all, I will go to S3. Like I said before, S3 is a service where we can store some data, and I need to prepare this data set. So let me go there. I already have got some buckets here, but I don't care about those. I will create something completely from the scratch. So let me click on the create bucket, and I will call my bucket Tomasz IT non-stop. Let me uncheck something because we won't need it, and let me create a bucket. And after a couple of seconds, the bucket will be created. And of course, if I will open it, it's empty because this is a new bucket, no objects, no files. But later, this is the place where we will store the images, which we'll later use to train our model. And also, this is actually the place where we will be hosting our website, because we can use S3 for this. So why to complicate if we don't need to do it? So we will be hosting our website here. Okay, so what kind of the website? I'm not a great developer, I will be totally honest with you, but I have prepared a website. This is a very simple HTML website, some kind of styles to make it a bit more like better, and pretty much some kind of scripts which will take the photo from the camera and it will save the photo somewhere. Where? So in this script, there is this place, bucket replace me. And for those of you who will want to do this what I'm doing today with you later by yourself, you will find those scripts on my GitHub. Okay, so if you will find GitHub Tomasz Stachlewski, you will find also those scripts. But long story short, this is the place where I need to change the name of the bucket, because I will want to store my pictures in my bucket, which I just created. So this was the name of my bucket. I will replace it, I will save it, and that's all. So now what I will do, I will just upload here this website. So I'll click on upload, add files, and pretty much let me find this was page HTML. I will make it publicly accessible, and that's pretty much all. So currently I have got a website here. If I will open it, if I will open the link in the different window, I will see how the website looks like. Nothing fancy. Again, we don't need to have fancy website here, but pretty much it will do the job. It's asking if I want to allow it to use my camera. Yes, I want to allow it. So pretty much how does it look like? Here in the top, you see a white square. Why is it a white square? Because I have got next to me another camera. So I will show you. So I have got a pig now. I will put it over there, and you see a pig on the browser because there is another camera. And how does it look like? So because I will be preparing a data set, a training data set, which I will use later to build my model, first I need to prepare some pictures of a pig. So I will need to say that now those will be pictures of a pig. And what I will do, again, I will take the pig to my hand, I will put it in front of the camera, and I will click on screenshot. Now, if everything worked, if I will go back to S3, I will see that I have got a new folder, images. Inside of it, I have got a new folder, pig. Why pig? Because this was the label which I used. And inside of it, I will have got one picture, the screenshot which I have taken. A long story short is like this, that I need to take a couple of those because my machine learning model will need to know how the pig looks like. So I will need to take a couple of those. So let me do it like this, and let me just, from different directions, so the model would know how the pig looks like. Maybe one more like this. Okay, So now if I will go back to S3, I will refresh, I will see that I have got 40 pictures of the peak. And this is what we wanted to achieve. But of course, our model need to know better. It will not only detect how the peak looks like, but also the other stuff. So now I will take the different object, the duck. And now I will be saying this will be the duck. Okay, so again, pretty much the same idea. I'm just taking the picture. Okay, this is how the duck looks like. Okay, and again, if I would go back to S3, if I will go to images, I will see that I have got a second folder, duck. So let me do maybe one more. So this will be pretty much a cow. At least I think this is a cow, strange cow, but this is a cow. So let's take a couple of those, cow, cow, cow. Okay, so we have got a cow, and maybe the last one, we will take this one. This is like a figure. This is figure. I guess some of you will know this. This is like from Dragon Ball. So let me take, so not only animals, but okay. Okay, so pretty much now if I would go back to S3, I will refresh. I have got 4 categories: cow, duck, figure, and pig. And let's stay with those because we also don't have so much time. So pretty much we finished the first part. We have got a data set which we want to use to create a model, ML model, and how to do it. Actually, on AWS, there's a couple of different ways how we can do it. But in this case, we will be using something which is called a SageMaker. So like I said before, ML platform. Later, I will tell you about other ways how we could actually do it. But meantime, let me go to SageMaker. So pretty much the service to build your own ML models. And about the SageMaker, I could, spend hours talking. We don't have a time, and this is not the objective of the session. So what I want to do on the left side, there's a section notebook. And here I already created like an hour ago a notebook which is called IT Nonstop. And I will just open it. I didn't do anything with it before. It just takes like 5 minutes to create it. So I didn't want to waste my time now. So that's why I created it before. This is actually using a notebook, Jupyter Notebook, a very popular open source solution, which is very often used by the data scientists and not only. And long story short is that you can use Jupyter Notebook to prepare a notebook. Those are like a pieces of scripts which you can use to, to do something, to visualize data and so on. Currently, I don't have anything here, but I already prepared before a notebook, which I will now upload. So let me upload something. This is this file, upload, and now I will just open it. Again, you will find this notebook on my GitHub, but don't worry, I will describe what is happening here. So pretty much there's a few of different pieces of codes, and pretty much each of this piece of code is doing something. At the beginning, we are saying we need to define what is the name of the bucket where we have got our pictures. So pretty much I need to modify this because my pictures are in the bucket which we called Tomasz IT Nonstop. So let me copy this, let me paste it, and that's all. The data set name images. So the subfolder is images. So now if I have got this piece of script, for those of you who have never worked with Jupyter Notebook, I can select it and I can click run. And then on the left side, I see that in the brackets, there is a number, which pretty much means that this piece of script, this part, was already executed. And now there is like a 20 or something like this parts of the code. I won't go by one because it doesn't make sense. So I will just say run all of them. just give me 1 second. I will modify one part. I will later tell you why I did it. So let me go above, and again, cell run all. And that's all pretty much. So now you see that in those brackets, there is like sometimes the number, sometimes the star. The star pretty much means that this is currently being executed, or it will be executed. Now you see that there is a digit, so this means that this part of the script was already executed. In this case, this part of the code, without going into the details, what does it do? It's saying, I will have got an image classification problem, because this is the problem which we want to solve. We will have got multiple images, and we'll want to say, is it a pig? Is it a duck or something else? And because we are in the cloud, we are in the AWS, we don't need to do everything from the scratch. Actually, what are we going to use? We are going to use build algorithms provided by AWS. So there is a Docker image which already has got implemented a solution for building image classification model. And pretty much I'm saying use it because I have got this kind of a problem. If I will go below, there's a piece of the code which pretty much is responsible for retrieving my pictures and creating a different format, because most of the algorithms, ML algorithms, will expect that they will get the data input in very specific format. And in our case, we have got like multiple images. So they need to be converted, and this is what is being happening here. You can also see that currently it detected that there are 4 categories: a cow, a duck, a figure, and a pig. So this is the place where it's being converted. So you can also see this part. ML model, which we are building, will be responsible for detecting what is on the picture, but it won't know that it won't tell you this is a cow, this is a pig. It will tell you this is 0, this is 1, this is 2, this is 3. So it's up to you to map the number to the class. So pretty much this is what it's saying. So it's saying, to make long story short, whenever I will say 0, it means cow. Whenever I will say 1, it means duck. Whenever I will say 2, it means figure, and so on. If I will go a bit below, and let me go. Oh no, one more thing here. This part is also quite interesting. So like most of ML algorithms, whenever you are creating your own model, you will break the data set into at least 2 data sets. One will be the training data set, and the second will be the test data set. And in this case, we are saying take 70% of the initial data set, so 70% of the pictures, and use it to build the model. And then take the 30%, the rest 30%, and this we will use it to validate, to test if our model is correct. So pretty much everything is being done automatically here. So we can go move on. There are some pieces of code which are not the most interesting, important. Pretty much it will upload again those pictures in a different format on S3. We don't need to know it. It's just how usually we do it. So let me go a bit below, because this is when interesting things happen. Currently, we're working on the Jupyter Notebook, which is a server. But this is quite small server. We actually are not using this server to train the model. I want to train it on a different server. On what kind of a server? Here I have got information. I will increase this a bit, that I want to train it on one server, and the size of the server is P3 2x large. If I would go into the documentation of AWS, I would see that it has got GPU, so graphic cards, to increase the speed of training the model. After all, we don't have a lot of time. This is a conference, so the time is quite crucial. So this pretty much define on what kind of infrastructure I will be actually building my model. So SageMaker also behaves like this, that when it will reach this step, or the next step actually, it will create a server next to this one with GPU and so on, and this server will be used to train the model. But as soon as the model will be trained, the model will be taken and put it here, and this server disk with GPU, this P32X large, will be removed. This is very important because those servers usually are quite expensive, because this is a GPU, graphic cards, and so on. So pretty much the long story short is that you want to get rid of the server as soon as you have got a model. And this is what will be done automatically by AWS. So let me go a bit below, and here is the magic is happening. Start the training. You can see that there is a star currently, so it means that currently this part of the code is being actually executed. And we can actually see in the logs what is happening here. We see that there are some epochs. For those of you who are not familiar with ML, epochs, to simplify a bit, means an iteration. And I didn't describe it, but before there was a declaration that I will have about 30 epochs. So 30 iteration to try to build the best of the best model. And I see that at the beginning with the epoch 0, the training accuracy was 65%. So not the best, not the worst, but we could do it better. And if I will go below, you see that at the end, actually, the training job completed, the training accuracy actually was 100%. So we have got a very good model. Why is it? Let's be honest, this is a very simple data set. So it's really easy to distinguish that this is a duck and this is a cow. So that's why we got 100%. We also get information that the training seconds, it took 182 seconds to train it. Is it important? It's very important because, like I said before, we are paying for this part. And I prepared before like a small Excel file to show you something. So I'm using this server, P32X large. And sorry for this. So this is an hour, this is a minute, this is a second, and this is the price. This is the time. So pretty much this server costs, this is not important, this server costs about $5 per hour. This server costs like 7 cents per minute. In our case, we were using the server for 180, I think, 2 seconds. So it cost like about 24 cents. So this is how we know how much we paid. Okay, so at this stage, we have got the model, but we will want to use it. So later what we are going to do, we will use it, but first we need to deploy it. So the last important part here is saying deploy. So what we are doing here, we are taking the model which we trained and we are deploying actually on the server. This time it's like T2 medium, so quite small server because we don't want to pay for it. Again, we see that there is a star in the bracket, which means that this model is actually currently being deployed. So let's see if it's actually the case. Again, I'm in the AWS console. Again, I'm in the SageMaker. And on the left side, I could go to the inference, and in the endpoints, I will see that, look, this thing is being currently created. So this is the endpoint. This is the server on which our model, which we trained, is being currently deployed. It will take about 2-3 minutes more. And after this, it will be automatically deployed. And actually, there will be a RESTful web service which we could use, which we would be able to use. But we need to wait. We need to wait, but again, also to not wait, let's start doing the last part of our application, because like I showed you before, pretty much we still are missing this part. We want to have also the possibility to test our application. We want to have a website where, again, there will be like, a possibility to capture something from the camera, and then we will say classify. The image will be saved on S3, even though it's not shown here, and the Lambda microservice will ask ML model, which is currently being deployed, with what is on the picture. And the model, if it will work, it will tell us there is a duck, there is something on the picture. So let's start building this part. First of all, let me start doing the Lambda part. So again, I will go to AWS console. I will open a new service, Lambda, because I will need to create this proxy for my application. So let's create a function. For those of you who have never used Lambda, Lambda is a serverless microservice. We write a piece of the code. We don't need to care about the infrastructure. It will scale automatically. If we don't run it, we don't pay anything. So perfect solution for our case. So to create a Lambda function, it's like really easy. We need to provide a name. I will say IT non-stop proxy AI. I need to choose the language in which I will write the code. In this case, I will be saying this is a Python code. And I will also specify the permission. So I already created this before, Lambda full access. And let's create it. Okay, so I have got my Lambda. But if I will go below, I will see that this Lambda currently is not doing anything special. It's some like hello from Lambda. And of course, we need to modify this. And again, I'm a bit prepared. So I prepared before a piece of the code. This code has got like 55, 54 lines of the code. Not the biggest, maybe not also the smallest, but actually quite easy. So let me copy this and let me paste it here. So this part of the code, again, to make it clear, will be responsible for fetching the request from the website, which we will do, and it will be responsible for reaching the endpoint, which probably is already deployed. We have got our model there, and we'll say, hello, Mr. Model, what is on this picture? There's one thing which we need to replace here, the bucket. Again, we need to say what is the bucket which we are using. So let me again copy the name of the bucket. It was Tomasz IT nonstop. Let me paste it here. Let me deploy it. And that's all. Okay, so the last part, this part, the website. The website. So again, I'm prepared. So I also prepared a file which is called validate HTML. This is a very similar website which we saw before, but this time we will be using this to classify something which we are showing in front of the camera. Again, we need to change like two things here. So let me find those places. Again, bucket replace me. So I will paste it here, the name of our bucket. Why is it like this? I will describe you this in a couple of seconds. There's one more thing, function name. We just created a Lambda function. Lambda function will be a proxy between our website and our model. We are calling this Lambda from the website. So we need to provide the name of this Lambda function. Otherwise, the website doesn't know where is the code which should be executed. So let me go for 1 second to our Lambda. This was the name. Let me paste it, save it, and that's all. Okay, so this is now our website. Let me now deploy it again on S3. We could use any service for this, but let's use S3 to not complicate our life too much. So again, I will go upload, and I will just paste the file which I just showed you. And again, I will make it public. So now I have got the second file, validate HTML, and I will open it in the browser. So this is the website. Quite similar like before. Again, you see that I have got like a possibility to put something in front of the camera. It works. But this time I also put some additional information here. So pretty much what is here. First of all, because our model will be responding, like I said before, 0, 1, 2, or 3. It's not saying a dog. It's not saying a pig. We need to map it. So here's the place, the categories which I can use to provide the names of my classes. Of course, I could also implement it in multiple different ways, but I decided to do it here. So where I will find it, let me go for 1 second to the SageMaker, because actually this was a good place to take it. So cow, dog, figure, and the pig. So I will paste it here, and I will just remove the additional parameter space. And now the endpoint name. My website will be calling my Lambda, but Lambda also doesn't know where is the endpoint because we didn't configure it. So in my design, in my website, I'm actually saying this in the website. This parameter will be sent to my Lambda, and then my Lambda will know based on this which endpoint, which model it should call. So let's see if our model is already deployed. In service, the endpoint is in service, so this is the name. It's quite random because we didn't specify, we didn't provide the name. So let me copy this and let me paste it here. And that's pretty much all. If it will work, as soon as I will show something in front of the camera and I will click on classify, what will happen? This website will take a picture, and this picture will be put on S3 with the name validate something. Then the Lambda will be called also, and the Lambda will call the endpoint where the model is deployed and will ask, hey model, what is on the picture? The model will say 0, 1, 2, 3, and then it will be mapped with those categories: cow, duck, figure, and pig. And we'll see, what is the response. There is a chance that it won't work like live, but let's see. So first of all, I'm taking the cow. Let's see if this is a cow, and let's classify this. It's thinking, and it doesn't work live. Let's see why it doesn't work. Let me quickly go to my Lambda. Let me go to the logs. At least now you see that it's live, Let me go to the logs, to the Lambda. Let me go also here. Sometimes this is the situation. Sometimes it doesn't work, and we never know what's the problem. But I think this time this was the duration. So let me fix something, and then if it will work, I will tell you why I changed this. Okay, but first let me change it by myself, and if it will work, then I will tell you what was the problem. Okay, let me try again. So I'm putting the cow, classify. Good. I was a bit nervous. So before we'll get to the response, I will tell you what was the wrong. Lambda, this microservice, there is a default timeout. The default timeout is 3 seconds. In this case, it took like a bit over 3 seconds to get the response, because in the code, I'm also waiting for something. So it pretty much there was a timeout. I modified this to be a bit bigger, and now it worked. And how it worked? It said me that this is a cow. For 91%, this is a cow. We also see that the duck is like 1%, figure 2%, pig 4%. Okay, so let's play more. Okay, so let's see what is this actually. And this is a duck for 99%. Okay, so the peak this time, maybe this one. A peak 95%. Let's do it now like this. 85%. And let's see, the Dragon Ball stuff. It's a figure 80%. Of course, there's a question, what will happen if I will put something else in front of my camera? So let's say I will take a ball. I'm taking the ball, I will put it in front of the camera. What it will be? A duck. Of course, it doesn't know that this is a ball because we didn't train it in such way. So it's saying it's a duck, but also with the response, we see that it's only 42%. We could also see, okay, what is this? A cow. I would prefer to be like a figure or something, but we need to stay with what we have got. So my hand looks like a cow in this example. So pretty much we managed to do it. We trained the model, we then use it in our website, and now we are able to classify different objects which we have got in front of the camera. Okay, pretty much we are almost at the end, but I would like to describe you a few more things. Before I told you that there is actually a couple of different ways how you could make this application at AWS. A different way which we could use actually is to use a service which is called recognition. A recognition is a service which is for solving this kinds of problem, like what is on the picture. And long story short is like this, that there are like multiple different models which are already built, trained. So for example, we could actually throw a picture of something and probably it will tell me that it's a duck or something. But sometimes we have got not standard task, and then we have got not standard labels, categories, and then we would like to create our own model. And then we still could actually use the service, but in this case, we would be using this first thing, which is called custom labels. And this would actually allow us also to create the model based on the setup which I would show you. So why I have decided to use SageMaker, not recognition. Both of them would be fine. The thing is that because I use the SageMaker, I actually have got a model here. This is the model which we created. And now what I could actually do is I could take this model and just, take it away from the cloud. I could deploy it on my own hardware. I have got with me here, for example, something which is called a deep lens. A deep lens is a camera on which we could actually deploy this model, and then we could put this camera, not like a laptop camera somewhere. This model would be deployed there and on the camera, and in the real time, it will be like detecting what is in front of it. So what is the difference? What is the difference between this setup and the setup which we have done? The difference is like if we would deploy the model here, the inference, the classification is being done on the edge, on our hardware, on our deep lens, on our Raspberry Pi, whatever we have got. On this setup which we have done, the recognition is being done in the cloud. So pretty much the picture needs to be sent to the cloud, in this case to S3, because the model is deployed on the cloud. Both ways are okay. Everything depends what is our use case, what we want to achieve, but it's worth to know that there are multiple different ways how we could do it. Definitely going with the recognition service would be easier, because then we don't need to know this stuff. We don't need to create a notebook, but we would just put some pictures and everything could be done automatically but by AWS. So again, like with typical situation with AWS, you can actually achieve a result by going with multiple different paths, and everything depends on your skills, your objective, and some additional things which are important for you. In this case, we trained our own model, which was the case. So pretty much, guys, this is end of my part. So we managed to do it. We managed to build the model. We managed to build it and train it, and it's actually detecting the things. There is no dog because I didn't have a dog toy, but the pig, the duck, the figure, and the cow, it's definitely there.